Okay, moving on to 14.6, we will be graphing quadratic functions. They kind of guide you through a step-by-step in the Hawk system, and you might want to incorporate desmos.com. So looking at the first two problems here, number one, and then I forgot to number this is number two from your note packet. The first thing they ask you to do on step one generally is to change this function that's in standard form into kind of a completed square form, which you can spot the vertex, sometimes called vertex form. So remember, to complete the square, we take half of b squared. So we're going to take half of 2 squared. So half of 2 is 1, and 1 squared is 1. We're going to put a 1 right here. Okay. Now, this is kind of new to us here. We're going to put a plus 1 here. So since I put a plus 1 here, I'm going to put a minus 1 here. So the net value of that is 0. Okay. And then at this point, this piece right here is factorable. So I get y equals x plus 1 quantity squared. And then here I get minus 4. Now the advantage of this form of quadratic function is that from this form I can immediately see the vertex. And so the vertex of this parabola or quadratic is, I take this value here and bring it off and change its sign. Kind of, it's a positive one, so I write negative 1. And this one I don't change the sign on. And that's the vertex of the parabola, where the parabola changes direction. So I've already plotted that here. There's -1, -4. Okay. Then the next thing you're going to have to do is find the line of symmetry. Well, the line of symmetry is always going to run vertically, and it's going to go through the vertex. So I have this line of symmetry drawn in here, and it is always through the x part of the vertex. So I have x equals -1 is the line of symmetry. Okay. Then they ask you to find the zeros, and what that means is we're going to let the y value of the function equal 0. And when I do that, we'll look and get something quite familiar here. We get a quadratic that we can solve using the quadratic formula or factoring, completing the square. There's a lot of methods we could use to solve this quadratic. Since this one is factorable, I can factor this into x plus 3, x minus 1, and I find out that x equals -3 and x equals 1. So what I get here are 2 points. I get -3, 0, and 1, 0. And those are sometimes called the x-intercepts, or the zeros of the function. So we let y equal 0 to do that. So I've already plotted those. I have 1, 0 plotted, and then I have -3, 0 plotted. And then the last thing they often ask you to do is to find 2 other points on the graph. Now you could use your TI-84 and the table feature, but another way to find points is to find points. We can just pick x values and then get y values. So looking at one example here, we can say let x equal 2. Well, if I let x equal 2, I could go back into either one of these equations, the original one or the completed square form. And what I get is I get y is equal to 2 squared plus 2 times 2 plus minus 3. And I get y is equal to, let's see, 4 plus 4 is 8, minus 3 is 5. So when x was 2, I get y is equal to 5, and I plotted that point already also. So you know you're going to have mirror image points here, so if there's a point here, you're going to have the point over there also, and you can kind of work that way. And then, you know, it takes kind of a skill that even drawing on a whiteboard, it's tough for me to do, but you get a parabola here. Now you won't have to draw the parabola because the Hawk system will plot it for you. And there's the parabola. This point is the vertex, and it's actually the lowest point, so it's a minimum. Okay. So on this one, we'll do the same thing quickly. We'll complete the square. So we take half of 6 squared. Half of 6 squared is 9. And so I'm going to subtract 9, so I have a net value of 0. I get y is equal to x plus 3 squared plus 4. I get a vertex at -3, 4 is the vertex. I already know this is going to open up, because if the a value is positive, okay, if a is greater than 0, it opens up. Okay, so I know there's a parabola hitting right here at -3, 4, and it's going to open up. So this point right here is going to be a minimum. Okay, then what I'm going to do is I'm going to try to find the zeros here, and I have 0 equals x squared plus 6x plus 13, and this is not factorable. You can try, but it's not going to factor. And what you can do then is you can use the quadratic formula. We have a piece of the quadratic formula that's called the discriminant. And when I do the discriminant for this problem, what I find out is I get -16. Now I've already calculated that on the note sheet, and I want to point that out that at this point we know that we have no real zeros. So the parabola is not going to cross the x-axis, and we can see that because the parabola is going to open up here. Okay, and then what you're going to do is you're going to find some other points on the parabola. So pick some x's, and then generate some y's by putting them into the. So you could put 1 in here for x or 2, but you could also use the table on ATI 84, and you might have to research that a little bit on YouTube, but you type this function in and use the table feature. So I already know kind of what's going to happen because I've done that, and I get a parabola that opens up here, and it kind of has our standard shape because our a value is equal to 1, and that's what the parabola looks like. So hopefully that helps a little, and we'll look at 2 more examples. It was kind of quick, but use the note sheet that I have written out for you also, and explore on YouTube a little bit.